I am from Centum Academy. So this is a question that is asked by one of our students. So I thought I could just discuss with everyone because this is a unique question and you will learn something from this question. Okay. So let us see what is this scenario. All right. So this refers to a figure. All right. It shows a cylindrical tube of volume V which has adiabatic walls. So the entire cylinder, this from here, the entire cylinder is adiabatic. So it cannot exchange heat from the surrounding. Okay. The internal energy of this ideal gas can be written like this. So there is a formula for internal energy that is given. So you can directly get the value of internal energy by using this formula. U is equal to 1.5 times nRT. Fine. So the tube is divided into two equal parts by a fixed diathermic wall. All right. So there is this diathermic wall which is fixed. Fine. So this wall is fixed. So what does it mean? It means that the volume of the left part and the volume of the right part will remain fixed. Fine. So initially the pressure and temperatures, they are given on both sides. Okay. So since it is the partition is dividing the entire volume equally, the volume of this side will be V by 2 and that side also the volume is V by 2. Okay. So the system is left for sufficient time so that temperature becomes equal on the two sides. So this system is left for long time and this diathermic wall, what it will do, it will conduct heat from the higher temperature and it will give the heat to the lower temperature. Okay, and it will conduct the heat till the point where when there is a temperature difference. Okay, so as soon as the temperature becomes same or uniform, the heat transfer will stop. Okay, so in order to solve this question, let me assume that T1 is more than T2. Fine. So, so when the diathermic wall conduct heat from T1 and take it away and give it to T2, the temperature T1 will go down, right? So T1 will go down and T2 will go up. Fine. So the common temperature reached will be what? Will be in between T1 and T2, right? So let us say that common temperature is T0. So T0 will be greater than T2 and it will be less than T1. Fine. So assume that uh, both the parts of V by 2 volume, they will reach the temperature T0. Now we need to find what is the value of this temperature. Okay, let us try to see what is happening here. So if I say that delta Q amount of heat is taken from left side. Okay, so how much heat the right side will gain? It will gain the same amount of heat. So delta Q is gained by the right side of this cylinder. Okay, now you will see that the volume of left side and the volume of right side, they're remaining constant. Okay, so if I apply first law of thermodynamics to, let us say, the left side, so delta Q will be equal to delta U plus W. Fine. And since volume is fixed, the work done will be 0. All right. So whatever heat that is taken from the left hand side will completely result in change in internal energy of the left side of this cylinder. Okay. And also similar argument can be made and we can say that whatever heat is received by the right hand side is equal to change in internal energy of the right portion of this cylinder. Okay, so hence I can say that from this equation number 1, I can also say that mod of delta U, the magnitude of change in internal energy from the left hand side, will be equal to the magnitude of change in internal energy of the right hand side. Fine. Why I have taken magnitude? Because it may happen that the change could come out to be negative, because for the left hand side the temperature is going down. Fine. So since temperature is going down, the change in internal energy will be negative. But I know that magnitude wise both change in internal energy from the left will be equal to the change in internal energy of the right portion. Fine. So delta U of the left part will be what? Number of moles in the left part, okay, into, so internal energy, there is a direct formula given. Fine. So I can say that it is 1.5 times number of mole on the left part into R multiplied by change in temperature. Fine. So it has gone from T1 to T0. Fine. So T1 being the higher temperature, so it will be T1 minus T0. Fine. I want to make it a positive number because I want to just equate the magnitude. So I'm subtracting lower temperature from the higher temperature. This should be equal to change in internal energy of the right hand side. That will be equal to what? Again, 1.5 times number of moles on the right hand side into R, that multiplied by higher temperature this time will be T0 minus T2. Okay, so T0 is the common temperature which we are trying to find, right? So keep that in mind. So let me simplify this. So 1.5 and R, they'll get cancelled out. But here N1 and N2, they are coming. So how will I, write this number of mole in terms of the quantities which are already given? What are the things that are given? Pressure, temperature, and volume, they are given, right? So if I write down the ideal gas equation, PV is equal to nRT. This, if I write for the right hand side, then I'll be writing it like this. It will be P2 into V by 2. This will be equal to N2R T2. Fine. So from here, I will get N2 as P2 into V by 2 divided by RT2. Fine. Similarly, if you write down for left side, for the left side, if you use ideal gas equation, you'll get N1 equals to P1 into V by 2 divided by R times T1. Fine. So if I substitute the value of N1 from here and the value of N2 from there and modify this equation, what I'll get here is P1 into V by 2 divided by RT1. This is equal to P2 into V by 2 divided by RT2 multiplied by T0 minus T2. Fine. From here, I can cancel out V by 2 and the R will also go. Fine. So what I'll get simplifying this is P1 minus P1 by T1 into T0. This equals to P2 by T2 into T0 minus P2, right? So T0 will come out to be equal to P1 plus P2 divided by P1 by T1 plus P2 by T2. All right. So like this, you can get the value of temperature. Fine. So this equation 2 can be used to find out the common temperature once it is achieved. All right. Now, once you get the value of T naught, you can also get the pressures on both the sides. How will I get pressure? Again, I have to use this ideal gas equation only, which is PV is equal to nRT, right? So if I have to find the pressure on the left hand side, volume is V by 2, and temperature I have to write from equation number 2. So this is T naught, right? And the number of moles, if you're talking about the left hand side, you substitute for this. Okay, so like that you can get the value of pressure. Okay, and similarly you can also find the change, you can also find the amount of heat that is exchanged between left portion of the cylinder and the right portion of the cylinder. So that is delta U. So delta U is, this 1.5 times N1R T1 minus T naught. So T naught you have already found out. So like this, you can analyze the entire scenario and get the required values. All right. So I hope you have learned something today, and we'll come back with few more questions which are, unique, and you will learn a lot from them.